Hi, I'm Cai, a first-year PhD student at Cardiff University. I'm originally from Anglesey in North Wales and came to Cardiff in 2017 to start my integrated masters. When I'm not doing PhD stuff, I play guitar, sing, and try and catch up on sleep. My working thesis title is Unlocking the Mechanisms of 29P's Outbursts by Catching Comets in the Land of Dragons. Very pretentious sounding, I know. My project split into two main parts, the photometric analysis of 29P and school outreach via a project called Comet Chasers to encourage and nurture interest and understanding in cometary science and astronomy. But what is a comet? First, grab some ice from the outer regions of the solar system. This can be water, methane, ammonia or carbon dioxide ices, anything you can get your hands on. Add rocks and dust, and send it on its way around the sun for a couple of years, centuries, or longer if it needs. You'll know you've done it right when you get an icy dirt ball. This is the nucleus. Cloud of gas around that called the coma, and some distinct looking tails trailing from it as it gets closer to the sun. Let's talk about Comet 29P, or 29P Schwarzmann-Wachmann 1 to its mother. It was discovered in 1927 by Arnold Schwarzmann and Arno Arthur Wachmann in Hamburg, Germany. I'm afraid I've already lied to you a little bit. 29P isn't actually a comet. It shares characteristics with both comets and asteroids, making it an object called Centaur. Yeah, and not like that. We believe centaurs were created similarly to comets, probably in the Kuiper belt, but their highly elliptical orbits are disrupted by the gas giants. And 29P has a near-circular orbit, a bit further than Jupiter at around 6 AU from the Sun, and an orbital period of just under 15 years. Since its orbit's so circular, it never gets close enough to the Sun to form a tail, but what 29P lacks in a tail, it makes up for in its activity. It's the second most active body in the solar system, just after Jupiter's volcanic moon Io, since it regularly goes through outbursts every couple of months. But what is an outburst? We think that 29P has cryovolcanoes, meaning volcanoes which, instead of the lava that we have on Earth, it spews out extremely cold gases. This happens when the side of the comet facing the Sun heats up the ices beneath the crust, turning them from a solid, skipping the liquid state straight into gas, which builds up pressure and eventually bursts through the surface, releasing the material. We can see these eruptions from Earth, since the brightness of the comet increases very suddenly. Because of its activity, 29P has become the most observed comet of all time, mainly due to a hugely successful amateur astronomer campaign with observers around the world. Despite this, 29P is still a mystery. Why are there cryovolcanoes? How fast does it rotate? How big is it? What does it look like? These are some of the questions I hope to answer in the coming years, but we need consistent data to start to answer them. That's where the second part of the thesis title comes in, Catching Comets in the Land of Dragons. I work with a project called Comet Chasers. We run sessions and create resources and experiments for teachers to teach cometary science and astronomy in schools in Wales. We give them telescope time with the LCO network via the Forks Telescope project, and pupils can request their own images and run analysis on them. If their images are used by astronomers, the schools are credited on real published scientific papers. This is a win-win situation. Schools have exciting real science to take part in, and astronomers get more data to analyse. Over the last year, I've been working on a set of online tools to guide students through the whole observing process, from planning to scheduling and finally to the analysis. It aims to simplify the observing procedure by removing unnecessary and complicated parameters that the pupils just don't need to know about. I've also been translating our resources into Welsh to get Welsh language schools involved too. That's where the Land of the Dragon bit comes in. It's a simple way to include more schools, and it gives opportunity to Welsh language schools, which are usually underperforming in STEM subjects. Know a school that would be interested in joining Comet Chasers? Send me an email at kai@cometchasers.org or tweet us at comet_chasers. Check out our website at cometchasers.org for more information about the project and for comet-based activities to do at home. Thanks for watching.